I want to solve some bigger problems as far as indicial equation is concerned. And I'm so pleased to inform you that all these concepts we are going to discuss here, they are one of the basic concepts that you'll be applying in your daily life indicial problems. So we have some set of problems here on the board. The number one, as it states, 2 raised power 10 plus 2 raised power 10 plus 2 raised power 10 plus 2 raised power 10. These questions are questions that you need in your bigger exams. You understand? Exams like GMAT and all that. So I'm going to give step-by-step solutions to this question here. So I'll start by solving the first problem. The first problem, as it states, says simplify 2 raised to the power of 10 plus 2 raised power 10 plus 2 raised power 10 plus 2 raised power 10. Now there are so many methods I can devise in solving this problem here. I can decide to assume 2 raised power 10 to be an alphabet. So I can say let 2 raised power 10 be equal to y, for example. So if I assume 2 raised power 10 is y, then anywhere I see 2 raised power 10, I will insert y. I end up having y plus y plus y plus y, y plus y plus y plus y. Now in that sense, remember that y plus y is 2y plus y is 3y plus y is 4y. So we are having 4y. Remember, we are not done. We have only expressed this thing in terms of y, which is not what we are asked to do. So if I decide to replace back my y, remember I told you before now that y has been replaced with 2 raised power 10. So if I decide to replace back my y with 2 raised power 10, I will have 4 times 2 raised to the power of 10. Now remember, I can actually express 4 in terms of 2. Remember, 4 is 2 times 2, which is a measure of 2 in 2 places, times 2 raised to the power of 10, which end up giving you, according to the law of indices, 2 raised power 2. Remember, multiplication induces addition. So we have 2 raised power 2 plus 10, which end up giving you 2 raised to the power of 2. So I believe with this concept now, you can solve as much as many problems as you can relating or involving indicial equation of this sort. We have the second problem, which we are asked to simplify as well. Now in this concept now, I would like to inform us that there is a rule that says a raised to the power of x times a raised to the power of y is a raised power x plus y. But always take note, is a raised power x plus y, yes. But always remember that there is no rule that guarantees you that a raised power x plus a raised power y is the same thing, never. But neither can you have it as this. Yes, it's not done. There's nothing like that. So automatically, when we have problems like this, how do we go about solving them? Now take note and take precise portion of what I'm going to do here. So shall we simplify together? Now I'm going to actually take terms with terms. So by so doing that, I would have 25 raised to the power of x plus 2 over 5 raised to the power of minus x times 20 raised to the power x minus 1 over 50 raised to the power 2x. Yes, it's virtually the same thing. Whatever thing you are having here is the same thing as this. Now remember, if you look at this here, automatically I think they are the same. I can actually work things out with this. So that means I can write 25 in terms of 2, which is the same, or which will probably be giving me 5 raised to the power of 2, in open bracket x plus 2 into 5 raised to the power minus x times 20. Remember, there is a condition to this, and that is what has been giving people problem in this aspect of things. Remember that this same thing here, we can rewrite 20 as 2 times 10. Yes, it's the same thing, but we have a problem here, and that's the power. Do you know that this thing here, do you know that 20 raised to the power x minus 1 is the same thing as 2 raised to the power x minus 1 times 10 raised to the power x minus 1? Yes, it's the same thing, very much the same. Or you can have it as 4 raised to the power x minus 1 times 5 raised to the power x minus 1, whichever one that suits your problem. But in this case, I think I prefer this as per the problem is concerned. So that means I can replace this with 4 raised to the power x minus 1 times 5 raised to the power x minus 1. So as the same thing applied to this. So do you know that 50 is the same thing as 5 raised to the power 2x? That's 50 raised to the power 2x. It's the same thing as 5 raised to the power 2x times 10 raised to the power 2x. Yes, let's now factor things out. Let's see what we can do with this. Now remember, look at this one. This one is the same thing as 5 raised to the power of 2x plus 4 when you expand with the 2 times there's another 5 raised power x minus 1 times 4 raised power x minus 1 all over 5 raised power minus x times 5 raised power 2x times 10 raised power 2x. Yes. Now looking at this thing here, there are things we can still do to them. You will realize that this one is having a base of 5, base of 5, base of 5, base of 5. Now let's work with the base of 5s and see what happens. And this one becomes 5 raised power 2x plus 4. Now since there's a multiplication sign binding these 5s together, automatically remember the concept. At the multiplication induce or prepare or allows you to add. And that's why we are going to add their powers together in this case. Times 4 raised power x minus 1. There's an x minus 1 here. All over, to apply the same thing here. 5 raised power minus x plus 2x times 10 raised power 2x here. And so we can still proceed. Let's then proceed with the solution here. And this one end up giving us 5 raised to the power. Now 2x plus x is 3x. Then 4 minus 1 is another 3 times 4 raised power x minus 1 all over. Now look at this one. Minus x plus 2x is a hex times 10 raised to the power of 2x. I still believe I can still break this one down. As remember 10 raised power 2x, you can express 10 or 10 as say is simply 2 raised power 5 or 2 times 5 rather. So which would end up giving you, that means I can write the whole of this thing as 5 raised power 3x plus 3 times 4 raised power x minus 1 over 5 raised power x times 2 raised power 2x. Let me use 5. 5 raised power 2x times 5 raised power, times 2 raised power 2x. Yes, it's the same thing. Yes, remember the concept. And this one gives us 5 raised power 3x plus 3 all over. I'm going to work everything together. All over 5 raised power, the whole of this one and this one gives us 3x times 4 raised power x minus 1 over 2 raised power 2x. And so let's work something out with this. This one gives us 5 raised power 3x plus 3. Remember, this one is more or less like division. And whenever you have division, you subtract. Times, now look at these two. We can actually do something to them. Remember, you can express 4 in terms of 2. Remember, 4 is the same thing as 2 places. Yes, this is what we end up having at the end of the day. And this one is the same thing as having 3x is 3. 3x minus 3x is out of it. So we are left with 5 raised power 3. Now, looking at these two here, you end up having 2. When you expand this, you have 2x minus 2. Remember, there is a division here. Division guaranteed you to subtract. To subtract with the power. So, and you end up having 5 raised power 3 times 2 raised power. Now, 2x minus 2x is 0. Then there is a negative 2 here. So, this one gives us 5 raised to the power 3 all over 2 raised to the power of 2, which is 125 over 4. And that is my preferred answer. Okay, quick one. Do you know or do you realize that 6 raised to the power of x plus 2 is the same thing as 2 raised to the power of x plus 2 times 3 raised to the power of x plus 2? Yes, that's a concept. So applying this concept into solving this problem now, we end up having or replacing this with 2 raised to the power of x plus 2 times 3 raised to the power of x plus 2. Yes, all these dots you see here, they are multiplication. That's Boolean dot product. So, and this 10 here, we can as well rewrite it as 2 raised power x minus 2 times 5 raised power x minus 2. Yes, the same thing. So, and this denominator here, 2 raised to the power of x. Yes, this one is very straightforward. Sir. Remember that if you try to express this one in terms of 2, this is the same thing as this. Times, replacing this, remember you can express 15 as a product of prime factor, and you end up having 3 by 5. And so if you try to rewrite this one here, so 15 raised power x minus 2 therefore 3 raised power x minus 2 times 5 raised power x minus 2. Applying it into this concept, we end up having 3 raised power x minus 2 times 5 5 raised power x minus 2. Now let's work with same basis and we end up having what we are expected to have. So I think I have 2, 2, 2. So let me work with the 2s first. So I have 2 raised power x plus 2. Now there's a multiplication sign binding these two. And remember, multiplication guarantee you to add. Divided by 2 raised power 2x times. Now work with the 3's. You end up having 3 raised power x plus 2. There's only a 3 here. So, and you should know that division guarantees you to divide. So subtract rather. So let me first have this one like this so that I won't congest the problem. Times 5 raised power x minus 2 over 5 raised power x minus 2. I think the problem is getting less soft. So from here, look at these two things now. What do we end up having here? So we have 2 raised power. Now x plus x is 2x. 2 minus 2 is 0. It's out of it. So we are going to be having 2 raised power 2x. Now remember, there's a division sign here. And division guarantees you to subtract. Times, look at these two here. We end up having 3 raised power x plus 2. Remember, I told you division, you subtract. Whenever you have division in indices, you subtract. And this one, you can actually cancel them out. 5 raised power x minus 2, 5 raised power x minus 2. That's a 1, no doubt. And so that can simply be left as this thing here. So automatically, we end up having, that means you can actually cancel this one out. So we end up having 2 raised power 2x minus 2x is 0. Times 3 raised power x plus 2 minus x plus 2 when you expand with the negative signs. Now remember, 2 raised power 0 is 1. So this one is also out of it. So we end up having 3. Are you with me? 3 raised power what? X minus x is 0. 2 plus 2 is a 4. And that's what? 3 in 4 places. And what's 3 in 4 places? That's 8. That ends up. That ends. That gives a solution to this problem here. So I believe, and I want to believe with these few examples, you can be able to solve problem relating indicial equation on your own. So we meet in the next class.